Right now you're sitting under a star that's been burning for 4.5 billion years. It's 93 million miles away, and everything you know, every sunrise, every season, every breath you take, depends on it staying exactly where it is, doing exactly what it's doing. But what if it just stopped? Not exploded? Not burned out over billions of years? What if the sun simply vanished right now, this instant? You wouldn't notice for a while. And that's the strange part. Let's walk through exactly what would happen, minute by minute, year by year, until the Earth becomes a frozen rock drifting alone in the dark. Here's something most people get wrong. If the sun disappeared right now, you wouldn't know it instantly. Light isn't infinite. It travels at about 186,000 miles per second, and the sun is far enough away that its light takes 8 minutes and 20 seconds to reach Earth. So for those first 8 minutes and 20 seconds, everything looks completely normal. The sky is still blue, shadows still fall the way they should. Somewhere someone is still getting a sunburn. The sun's photons already in transit keep arriving right on schedule because light doesn't care that its source is gone. It just keeps traveling until it hits something. And here's the part that surprises people even more. Gravity works the same way. For a long time, scientists debated whether gravity was instantaneous, but Einstein's general relativity settled it. Gravitational effects also propagate at the speed of light, so the Earth wouldn't feel the sun's absence and go flying off into space early. It keeps orbiting normally, tracing its usual path for that same 8 minutes and 20 seconds. Then at the same moment, two things happen at once. First, the light vanishes. Not a sunset, not a gradual dimming. One moment there's daylight or the sun sitting in the sky, and the next moment it is simply gone. Absolute darkness. Everywhere it was daytime. If it happened to be nighttime for you, you might not even notice right away, until the temperature and the sky itself started giving it away. Second, gravity's grip releases. The Earth has been orbiting the sun because the sun's mass bends space around it, and Earth is essentially falling around that curve forever. Take away the mass, and there's nothing left to fall around. Earth stops curving and instead flies off in a straight line. A straight line tangent to whatever point it was at in its orbit, at about 67,000 miles per hour. This isn't Earth getting flung dramatically. It's simpler and stranger than that. Earth just stops turning the corner it's always turned and continues on in a straight line, forever, into the dark. The moon, still gravitationally bound to Earth, comes along for the ride. So do all the other planets, each flying off on their own straight-line paths. The solar system unraveling all at once. With the sun gone, Earth's most obvious problem is heat. We think of the sun as light, but its real gift is warmth. It's the reason Earth isn't a frozen ball of rock like so many other places in the universe. Within the first 24 hours, without the sun's light, photosynthesis stops completely. Every plant on Earth that depends on sunlight to produce energy is instantly cut off. This doesn't kill plants overnight. Many can survive short, dark periods. But the clock has started. Temperature drop is the more immediate crisis. Earth's atmosphere and oceans hold an enormous amount of heat, so we wouldn't freeze in hours. But the drop would be fast and relentless. Within the first week, average surface temperatures could fall below freezing across most of the planet, even in places that are normally tropical. Without sunlight, the water cycle collapses too. No solar heat means no evaporation to speak of, which means the normal cycle of clouds and rain breaks down. Any moisture in the air would likely fall as snow, since it's rapidly getting far colder outside than the air is. Governments and people would likely respond by rationing energy for heat, moving underground or into insulated shelters, and abandoning farming almost entirely, since crop agriculture would be effectively over within days. By about 1 week in, models estimate Earth's surface temperature would already be around 0 degrees Fahrenheit, or roughly minus 18 degrees Celsius, in many regions. Comparable to a brutal winter in Antarctica, except everywhere. By 1 year, estimates from planetary scientists suggest the surface could plunge to around minus 100 degrees Fahrenheit, or about minus 73 degrees Celsius. For context, that's colder than the coldest temperature ever recorded on Earth's surface naturally. The atmosphere itself starts to change. As it gets colder, gases in our air behave differently. Water vapor freezes out first, falling as snow. Given enough time and cold, even the nitrogen and oxygen that make up most of our air could begin to condense and eventually freeze into a thin frost coating the ground, though this would take longer than a year to really set in. Photosynthetic life would be almost entirely gone within the first few months. Without plants producing oxygen and energy for the base of the food chain, animals that depend on them start dying off in a cascading collapse. Humanity's survival at this stage depends entirely on technology. Nuclear power, geothermal energy, and stored fuel to generate heat and grow food indoors using artificial light. It's not science fiction to say some humans could survive this way for a long time. The bigger question is how long the infrastructure and resources could last. Here's where the story gets more hopeful, at least for some life on Earth. Oceans have enormous thermal mass, meaning they store heat and lose it far slower than air or land. While the surface of the ocean would begin freezing within the first few months to years, that ice would act like a lid, insulating the water below it from the extreme cold above. Deep beneath the surface, geothermal heat radiating up from Earth's core and mantle, would continue keeping water liquid in certain zones, potentially for thousands of years. This is especially true near hydrothermal vents, cracks in the ocean floor where superheated, mineral-rich water pours out from inside the Earth. This matters because there are entire ecosystems around these vents that don't rely on the sun at all. Instead of photosynthesis, the bacteria at the base of their food chain use a process called chemosynthesis, converting chemicals like hydrogen sulfide into energy. Tube worms, certain crabs, and other vent species have never needed sunlight to survive, and they likely wouldn't even notice the sun was gone. So, in a strange twist, some of the most alien-looking life on Earth, creatures clustered around scalding cracks in the ocean floor in complete darkness thousands of feet underwater, could be among the last survivors of a sunless Earth. Meanwhile, Earth itself is still moving. Remember, without the sun's gravity, Earth isn't orbiting anymore. It's drifting in a straight line through space, carrying the moon with it, at about 67,000 miles per hour. Over thousands of years, Earth would drift further and further from where our solar system used to be, becoming what astronomers call a rogue planet. A planet with no star, wandering the galaxy alone. Eventually, and we're talking a very long time, potentially longer than Earth has existed, surface temperatures would approach close to absolute zero, around minus 454 degrees Fahrenheit or minus 270 degrees Celsius. Only slightly warmer than the background temperature of deep space itself. Any remaining atmosphere would have long since frozen solid onto the surface. Rogue planets aren't just a thought experiment, by the way. Astronomers have actually discovered real rogue planets drifting through our galaxy, untethered to any star, using detection methods like gravitational microlensing. So, this isn't just a hypothetical fate. It's a real category of world that already exists out there, and Earth would eventually join them. So, could life persist on a rogue Earth indefinitely? For surface life, the answer is almost certainly no. The cold eventually becomes too extreme for any biology we know of. But for the deep chemosynthetic ecosystems near hydrothermal vents, powered by Earth's internal heat rather than the sun, survival could theoretically continue for an extraordinarily long time. As long as Earth's core keeps generating heat, which itself would very slowly cool over billions of years. As for humans, our survival would come down to how much energy-generating infrastructure we could maintain. Particularly nuclear power, which doesn't rely on the sun at all. Self-sustaining underground colonies using nuclear energy, artificial light for growing food, and recycled water systems are the most plausible long-term survival strategy. Similar in some ways to concepts already explored for Mars colonization or long-duration space stations. So, that's the full picture. The sun disappearing isn't an explosion or a single dramatic moment. It's a slow, cascading unraveling. 8 minutes of eerie normalcy, followed by darkness, a plunge into deep freeze within a year, an ocean that ices over but hides pockets of life below, and a planet that drifts silently into the galaxy as a frozen wanderer. It's a reminder of just how much we owe to that one star. Not just light, but warmth, gravity, and the entire structure holding our corner of the universe together. If you found this as fascinating as I did putting it together, let me know in the comments what if scenario you want explored next. Thank you for watching this video, and for more like this, subscribe to Industrial Origin.